Wow, big metal birds in the sky. Have you ever looked up at the sky and seen an airplane? A huge, giant metal airplane just soaring through the air like it's no big deal? It's pretty amazing, isn't it? These incredible machines, some weighing hundreds of thousands of pounds, just cruise along miles above our heads. It makes you wonder, how in the world does something so heavy get off the ground in the first place and then stay up there? It seems like magic, but it's not magic, folks. It's science. And science is all about understanding how things work, even things as amazing as airplanes flying high above the clouds. Think about it. You drop a rock, it falls. You drop a feather, it floats down slowly, but it still falls. So how does a massive jet, full of people and luggage and snacks, do the opposite? How does it go up, 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 and stay there for hours? It's a question that people have been asking for centuries, dreaming of soaring like birds. Early inventors tried all sorts of wacky contraptions, flapping wings and hoping for the best. Some of them were pretty funny, but they didn't quite get the job done. It took a lot of smart thinking, a lot of experimenting, and a deep understanding of the world around us. Alright, science fans. To understand how airplanes fly, we need to talk about 4 special forces. That's right, 4. These forces are always at play when an airplane is in the air, kind of like invisible hands pushing and pulling the plane. They are called lift, weight, thrust, and drag. Say them with me. Lift, weight, thrust, drag. These 4 forces are in a constant tug of war, and when they are balanced in just the right way, an airplane can cruise smoothly. But if one force becomes much stronger or weaker than the others, things can get a bit wobbly, or the plane might go up or down. First up is weight. This one's pretty easy to understand. Everything has weight, right? You have weight, your backpack has weight, and airplanes definitely have weight. Weight is the force of gravity pulling the airplane down towards the center of the Earth. Gravity is always trying to bring everything down, and it's a pretty persistent force, so for an airplane to fly, we need something to counteract this downward pull. That's where our next force comes in, and it's a real superstar in the world of aviation. It's the force that says, "Not today, gravity." That superstar force is called lift. Lift is the upward force that pushes the airplane into the sky, opposing the force of weight. Lift is mainly generated by the airplane's wings thanks to their special shape and the way air moves around them. We'll dive deeper into how wings create lift a little later, because it's super fascinating science. For now, just remember that lift is the hero force that fights against weight, allowing the airplane to leave the ground and stay airborne. So we know that lift is the amazing force that pushes an airplane up, defying gravity. But how do wings, those long flattish things sticking out from the sides of the plane, actually create this lift? It's not just because they're there, it's all about their special shape and how air flows over them. This is where a very smart scientist named Daniel Bernoulli comes into the picture. He discovered something super important about fluids, like air and water, in motion. And it's called Bernoulli's principle. It sounds fancy, but the idea is pretty straightforward and incredibly cool. Bernoulli's principle basically says that faster-moving air has lower pressure, and slower-moving air has higher pressure. Think of it like a crowded hallway. If everyone is rushing in one direction, fast-moving, they spread out a bit and don't push on the walls as much, lower pressure. While Bernoulli's principle and the wing's curved shape are super important for creating lift, there's another trick up the airplane's sleeve, or rather on its wing. It's called the angle of attack. Imagine the wing slicing through the air. The angle of attack is the angle between the wing and the direction of the oncoming air. If the wing is tilted slightly upwards at its leading edge, that's a positive angle of attack. This tilt plays a huge role in how much lift is generated, and pilots can control this angle to help the plane climb, descend, or maintain altitude. It's a bit like holding your hand out of a car window. When you tilt your hand up slightly into the wind, you can feel an upward push, right? That's similar to what happens with an airplane wing. By increasing the angle of attack, the wing deflects more air downwards. Now remember Sir Isaac Newton? He had some pretty smart ideas too, especially his third law of motion. For every action there is an equal and opposite reaction. Section 5. Full throttle, the power of thrust. Okay, so we've got lift figured out, at least the basics. But an airplane isn't just going to magically float upwards if it's sitting still on the runway. It needs to move forward, and it needs to move forward fast enough for the wings to do their lift-generating thing. This is where our friend thrust comes roaring in. Thrust, as we mentioned, is the force that propels the airplane forward. Without thrust, there's no airflow over the wings, and without airflow, there's no lift. So, thrust is absolutely essential for getting an airplane off the ground and keeping it moving through the sky. How do airplanes generate this mighty forward push? Well, it depends on the type of airplane. Many smaller planes use propellers. Propellers are like big spinning fans with blades that are shaped like small wings. As the propeller spins, its blades bite into the air and push it backward. And remember Newton's third law? For every action, there's an equal and opposite reaction. So, as the propeller shoves air backward, action. The air shoves the propeller and the airplane attached to it, forward, reaction. It's like a swimmer pushing water behind them to move forward. Pretty clever, huh? Larger airplanes like the big passenger jets you see at airports typically use jet engines. Section 6. Drag the air's sticky fingers. Now, while thrust is busy pushing the airplane forward, there's another force trying to hold it back. This force is drag. Drag is essentially air resistance. Think about sticking your hand out of a moving car window again. You can feel the air pushing against your hand, trying to push it backward. That's drag. Air might seem invisible and empty, but it's made up of countless tiny molecules. When an airplane flies through the air, it's constantly bumping into these molecules, and this creates a resistance force that opposes the airplane's motion. Drag is the universe's way of saying, not so fast. There are actually a couple of main types of drag that airplanes have to deal with. One is called parasitic drag. Section 7. Skydancing, how planes steer and turn. So our airplane is up in the air with lift conquering weight and thrust battling drag. But how does it turn? How does it go up or down on purpose? It can't just wish its way to its destination. Airplanes have special moving parts on their wings and tail that allow pilots to control them. These are called control surfaces. Think of them like the rudders and oars on a boat, but for the air. There are three main types of control surfaces that allow the airplane to rotate around three different axes: roll, pitch, and yaw. It sounds a bit like a gymnastics routine, doesn't it? First, let's talk about roll. Rolling is when one wing dips down and the other goes up, allowing the airplane to bank into a turn like a bicycle leaning over. This is controlled by ailerons. Ailerons are small hinged sections located on the trailing edge, the back edge, of each wing, usually near the wingtips. When the pilot wants to roll the plane to the right, the aileron on the right wing goes up, decreasing lift on that wing, and the aileron on the left wing goes down, increasing lift on that wing. This difference in lift causes the airplane to roll. It's a very coordinated movement. Next up is pitch. Pitching is when the airplane's nose tilts up or down. This is how the airplane climbs or descends. Section 8. Mind-blowing airplane facts. Science. Are you ready for some seriously cool facts about airplanes and flight? Prepare to have your mind blown, because the world of aviation is packed with amazing science and incredible numbers. For instance, did you know that the wings of a large jetliner like a Boeing 747 can flex up and down by as much as 20 feet during flight? That's taller than a giraffe. This flexibility helps the wings absorb turbulence and makes for a smoother ride. It's like the wings are giant, graceful shock absorbers, constantly adjusting to the air around them. Whoa, here's another one. The air pressure inside an airplane cabin is usually kept at a level equivalent to being about 6,000 to 8,000 feet up a mountain. This is called cabin pressurization. Without it, at the typical cruising altitude of 35,000 feet, the air would be too thin to breathe. So the airplane is like a sealed can, keeping the air inside comfortable and breathable for everyone on board. That's why your ears might pop during takeoff and landing. It's the pressure difference between the cabin and the outside air changing. Science is literally keeping you comfortable up there. Consider this: a modern jet engine can generate over 100,000 pounds of thrust. Section 9. The wonder of flight. Keep looking up. So there you have it, Science Explorers. We've journeyed through the amazing science of how airplanes fly. We've learned about the four fundamental forces: lift, weight, thrust, and drag. We've seen how the special shape of wings and Bernoulli's principle work together to create that magical upward force of lift. We've also touched on the importance of the angle of attack, and how engines provide the powerful thrust needed to overcome drag and propel these magnificent machines through the air. It's a beautiful dance of physics and engineering, all coming together to make flight possible. We also discovered how pilots use control surfaces like ailerons, elevators, and the rudder to steer their aircraft. making them climb, descend, and turn with grace and precision. For more fun and interesting facts like these, do like and subscribe.